Dr. Michio Kaku, who has written Hyperspace, Parallel Worlds, Physics Now of the Impossible. That's what we're going to talk about tonight, Physics of the Impossible. Dr. Kaku is an internationally recognized authority in theoretical physics and the environment. He holds a Henry Summit Professorship in Theoretical Physics at the City College and the Graduate Center of the City of New York. He has lectured around the world, and his PhD-level textbooks are required reading at many of the top physics laboratories around the world. Dr. Kaku graduated from Harvard in 1968, summa cum laude, and number one in his physics class. He received a PhD from the University of California at Berkeley Radiation Laboratory in 1972. He held a lectureship at Princeton University in 1973, joined then the faculty at the City University of New York, where he's been professor of theoretical physics for 25 years. What's impossible? Maybe not so much anymore. Invisibility, teleportation, starships, telepathy, time travel. Finding alien life in space impossible? Maybe not. We'll be right back. All right. Okay, to Dr. Kaku we go. Professor Kaku, welcome back again to the program.
Well, Art, glad to be on your show again.
It's great to have you. I had no idea you were going to write this book.
Yeah, and first of all, let me thank all your listeners out there and supporters. You know, you guys have supported the book, Physics of the Impossible, and you boosted it to number 12 on the New York Times bestseller list.
Number 12 now?
Yeah, that's right. It'll come on officially next week, but our publisher got the word in advance.
Wow, I bet they're jumping up and down.
On the New York Times bestseller list. And I'd like to thank you and all your listeners for supporting my work.
Well, thank you. Why did you decide to write this book?
Well, you know, when I was a kid, I had two role models. The first was Albert Einstein, and when he died, everyone was talking about his unfinished work, his greatest unfinished work, which was the theory of everything, and I wanted to be part of that chase to get the theory of all creation. But the second role model I had, well, I used to watch Flash Gordon a lot when I was a kid, but I realized very early that I didn't have blonde hair. I didn't have muscles. And I thought to myself, well, look at Dr. Zarkov. He's the man who built the starships. He built the ray guns and the city in the sky. And I said to myself, well, that's for me. So when I become a physicist and I know exactly the boundary between what is known and not known about physics, I'm going to carry on the tradition of Dr. Zarkov and write a book about invisibility, teleportation, telepathy, starships, antimatter engines, and time travel. All the stuff that we see in the movies.
Either that or you'd make a good cue.
Right. And, you know, some of the biggest Hollywood blockbusters have been based on precisely these kinds of science fiction gadgets, which are impossible, say most scientists, right?
Oh, yes.
Yeah, but I know that in the coming decades, coming years, centuries, maybe millennia, many of the things we see in the movies as Hollywood blockbusters will, in fact, be just engineering problems. They don't violate the laws of physics as we know them, and so I think they will be realized.
Well, I thought all these did violate the law. Invisibility, for example.
Yeah.
That's got to violate the laws of physics.
You know, I teach optics to my students, and I used to teach 2 years ago that invisibility was impossible. Like if you have a boulder in a stream and the water wraps around the boulder, then if you're downstream of the boulder, you know that, you cannot sense the presence of a boulder upstream. Now, we used to teach in optics that light cannot wrap around a boulder this way, violates the laws of optics. Well, I was wrong, and so was every single physics textbook on the planet Earth. 2 years ago, it was done. At Duke University and also Imperial College London, they show that if you take an object and shine microwaves around it, microwaves can, in fact, wrap around this object just like water around a boulder, rendering it invisible. And at Caltech and in Germany and at Iowa, 3 laboratories show that visible light, red light and green laser light, at least at the microscopic level, can also bend in a way just like wrapping around a boulder. So I think within a decade or so, we'll be able to make an object vanish, totally vanish, in one color, like red or green, and then the primary colors soon after that. And after that, Harry Potter, watch out.
Do you ever envision a day? I mean, we're talking about inanimate objects now, or at least I think we've been until this point. I read The Invisible Man long ago. God, the book was so much better than the movie. Would it be possible to make something biological invisible?
That's right. That's where we're headed. And it's no accident, by the way, that the United States Pentagon has been funding this research on what are called metamaterials. The Pentagon wants not just, stealth bombers and stealth fighters. Yeah. They want invisible soldiers. They want invisible jet fighters. And it's not going to be quite like the Harry Potter cloak, which is, of course, made out of cloth. It'll probably be a cylinder where light will wrap around the cylinder and reform at the other end so that a soldier or an airplane or a helicopter would be invisible.
Back up a little bit. What are metamaterials?
Okay. Usually when we teach optics, we talk about glass, we talk about water, we talk about diamonds, and that light cannot move in diamonds or glass or water in a way consistent with invisibility. It's impossible. Right. But metamaterials have tiny impurities in them. That's where we made the mistake. Tiny little impurities which kick the wave in a way such that you can wrap around an object. This stunned the world of physics. It was done 2 years ago, and now we're beginning to play with visible light. And it does mean that the concept of invisible soldiers, invisible helicopters is not totally out of the question, or for that matter, invisible aliens. If you figure that we're a few decades away from invisibility, if you have intelligent life forms in outer space that are hundreds, thousands of years more advanced than us, then naturally they may simply be invisible and not want to disturb us.
Well, if you wrap microwaves around me, I cook.
Yeah, right. Well, that's why you have to wrap it around the object so you don't cook what's inside. And we even have videos of this showing that the ultraviolet radiation can reform at the other end, and so you don't know that there was something inside this object made out of metamaterials. So this is causing an enormous amount of excitement. Everyone's jumping on the bandwagon now. Physics laboratories jumping in the game. Pentagon is funding this research. So we're going to see huge advances in something that was considered impossible just 2 years ago. It's been done. We've been there, done that now in the laboratory.
So you actually see on the horizon invisible people, soldiers.
It's conceivable. Now, there are countermeasures, of course. Every time you invent a weapon, there's a counter weapon. Right. If you have an invisible soldier, you can throw sand, and then you'll see the outline of the invisible soldier.
There you are. I remember in The Invisible Man, it would rain, and he would become sort of semi-translucent.
That's right. And you can also throw a bedsheet over the invisible soldier and capture him that way. So there are some countermeasures you can take that once invisibility is attained. But, our point of view is that it's very humbling. We physicists thought we knew the law of optics. We teach optics. We build fantastic lenses that can see millions, billions of light years into outer space. And yet we neglected to look at materials with impurities in them, tiny little impurities that can infinitesimally kick light microscopically so that it culminates in wrapping around an object and reforming at the other end.
So if I, as an invisible man, held $100,000 in hard cash in my hand, would it be visible?
Well, if I put it inside my cylinder or inside my cloak, it too would become invisible because light would then wrap around that object as well. And I would be inside this invisibility cylinder, and I could then bring, let's say, cash also inside. And so it's not necessary that, usually in these movies you have to be naked, and you cannot hold on to money. You can see the money. Here you don't have to be naked, and you can bring the money into your cylinder and walk away, and no one would know the better.
My goodness. Would you be able to move in this cylinder? In other words, walk or move around in some way, or
yes, and again, this does not yet exist, but it is an engineering problem now. It's the physics, the basic physics, has been demonstrated amply. Again, the motion pictures of this thing now. So yeah, it would be a little bit clumsy. A cloak would, of course, be ideal. And we've looked at a cloak, by the way. We had done some studies on whether or not, just like the movies, Harry Potter has a very flexible cloak. That would require that you can rearrange the molecules inside that cloak, and that's pretty hard to do. It's much easier to get a stationary cloak, like a cylinder or a sphere, and bend the light around the sphere that way and not have to worry about rearranging the atoms inside this object as you move.
So all light would, I guess all light would have to be rearranged, or you would see something.
Okay, well,
right?
Here's the catch. We think we could do it with one color easily. Like within the next few years, we'll probably make an object disappear to red light. But we, of course, can see three primary colors. And so you would have to have three layers to bend each of the primary colors.
Well, it's just like going to color TV from black and white.
Yeah. So we think we can do it. It's an engineering problem, but that's the main engineering problem facing us right now, is to how to get beyond one color to get all three primary colors.
Well, if you were, you'd have tremendous social problems associated with that. I mean, if you actually
potentially, Plato, believe it or not, 2,000 years ago, he worried about invisibility. He said that if everyone could become invisible, we could all rob, steal, do all sorts of mischief.
That's right.
And therefore, he said you have to have laws to rein in people's intentions. No human, he said, can resist the temptation to use invisibility to become the next king.
I think that's probably correct.
Yeah, so Plato said, therefore, we have to have laws. You cannot trust human nature. Human nature will be seduced by the power of invisibility, he wrote. And so that's why in the Republic, he said we have to have a state. We have to have a state to rein in the worst impulses of our best citizens because of invisibility.
Well, of course, any such invention would not reach the general citizenry first anyway. It would be, of course, invisible soldiers, right?
That's right. Well, they're the ones, the Pentagon is the one funding it. And, of course, these are not cheap materials, and they're very sophisticated. The ones built, at Caltech in Germany have microscopic implants, implants so tiny you can't even see. So it takes a pretty sophisticated laboratory to begin to construct these materials.
And things would be invisible before biological things, right?
No, you could make them invisible at the same time. Like if you can make a book invisible, you can make a frog invisible too. Whether it's animate or inanimate doesn't matter because they're inside a cylinder and light wraps around the cylinder. So whatever's inside becomes invisible.
Well, you and I both know there'd be invisible bombers before there'd be invisible people.
Well, that's why we have to make sure that the good guys get this technology first.
How is it that you do that?
Well, like I said, it's very expensive to get visible light to become invisible because these little implants, these little impurities, they have to be the size of like a transistor in a supercomputer, very, very tiny. Okay. And in fact, the same technology that we use to etch transistors, like 1 million transistors on your fingernail, that same technology is now being used to create these little impurities inside plastic so that light can then bend in a way consistent with invisibility. So right now we've only done it at the microscopic realm for visible light, but the proof of principle was done just a few months ago.
Well, what happens when you begin to apply some of the principles involved in nanotechnology with this?
Yeah, well, that's going to be where the big breakthroughs are. Once we master nanotechnology, then we may be able to bend this into different shapes. Not just cylinders, but all sorts of different shapes to wrap it around objects and to reform it. Once we can control atoms, okay, then we can start to make invisibility on a tremendously flexible scale. Different shapes, different contours, different colors. We'll be able to play with invisibility with nanotechnology.
Maybe it would all be backwards from the movies. Maybe when nanotechnology jumps in, as we got dressed, we'd disappear.
Yeah, that's conceivable, right?
Sure. With nanotechnology, the shirt, the pants, the shoes, the socks,
right.
And who knows, some little hood, and there you go. Literally. Yes.
Well, the well-dressed man of the future may not be dressed at all.
Well, that's right. So the movie's always had it a little backwards. Fascinating. God, now, how far out on the horizon, if nanotechnology comes along well, and it seems to be doing that, how far out on the horizon might some of this really begin to manifest itself in visibility, for example?
Okay, well, the key to creating flexible materials, different shapes that can change, different colors, would be nanotechnology. Another application of nanotechnology is teleportation. Aha. And now we're getting into the big leagues.
I just read the book Jumper.
Yeah. The technology exists already now on the nanoscale. The world's record, by the way, is we can teleport a particle of light called a photon from one Canary Island to another over a distance of 100 miles. That's the world's record.
Really?
The next world's record will be to the space shuttle. We're asking NASA permission to, on the space shuttle, have a laser apparatus that will receive a particle of light teleported from the Earth to the space shuttle.
Well, you better move quick. There aren't that many missions.
And then after 2020, it's the moon. After 2020, we're going to have a traffic jam in the moon when the Chinese and the Americans all go back to the moon. And at that point, we're going to teleport particles of light to the moon. Now, we can already teleport atoms of beryllium and cesium. That's been
really?
That's been done in the laboratory.
I had not heard that. I heard about the light. I think it was IBM, but I've not heard about anything else. What do you know about that?
Atoms of beryllium and cesium, and within a decade, perhaps the first water molecule. And after that, the first strand of DNA. This is coming. This is coming thick and fast. We're going to be able to teleport molecules in a few more years. And after that, maybe complex molecules like DNA, maybe a virus, okay? Now, Captain Kirk, of course, is more difficult. There are 50 trillion cells inside Captain Kirk. However, Star Trek takes place in the 23rd century. That still gives us a few centuries to master the art of teleporting cells, not just fragments of molecules. And at that point, you begin to wonder, who is this Captain Kirk? Because we just destroyed the old Captain Kirk. You have to be destroyed to be teleported, by the way.
And then reassembled.
Yeah, so if you create this other Captain Kirk over there, the old one died, but the new one has the same memories, the same information, neural circuits, memories, personalities. Who is this other person? So you begin to wonder what the soul means if you can teleport the information content of every cell, every memory circuit to this other person.
Well, I do wonder about the soul, Professor.
Yeah, and if if the original person died and is no longer there, and here you have this copy who insists that he is Captain Kirk, then for all intents and purposes, maybe he is Captain Kirk. And the soul got lost in the shuffle someplace.
Teleportation, would it always in your mind require an apparatus at the other end?
Yes, there are some limitations. The first limitation right now is we can only do it at the atomic scale, and molecular scale is next. And, of course, we're going to start to beam things into outer space as well. And you also have to have a receiving apparatus there. So on Star Trek, they simply beam people anywhere in the world.
Right.
In reality, you're going to have a receiving station.
So, in other words, you can only go where you have gone.
That's right. So there are limitations to what is called quantum teleportation. However, there's another technology that I mentioned in my book, Physics of the Impossible, and that is the atomic laser. Everybody knows that laser is made out of light. Everybody knows that. We play with it. But atomic lasers are coming too, in which case maybe we can just literally shoot atoms of something and reform an object at the other end. That could be coming.
All right. And stand by. We're at a break point here. An atomic laser. I want to know more about that. Yes, I have a little laser that my cats love to play with, a little red one. But an atomic laser coming right up. My guest is Dr. Michio Kaku, and we're talking about the physics of the impossible. His book apparently about to soar to number 12 on the bestseller list, and boy, that's fast. But I'm not surprised, because he's a brilliant man. Sunday, I'll be back with Dr. Stephen Greer. And I want to make a note here, because it's not on the list of things to be discussed, but Months and months ago, Dr. Stephen Greer said SETI had received a signal they weren't talking about. Remember that? Then, just a few weeks ago, it was all over the news. Yes, SETI had received a signal. It was one of those stories that hit and then dropped like a rock. They went on to say it was very complex, could take a long time to decipher, but they thought that it was extraterrestrial. So you might want to get hold of Dr. Greer and let him know I'm going to be asking about that. We'll be right back. Professor, just 1 second back to invisibility. If you make a soldier invisible, then would that soldier be able to see anything?
Well, there is a problem that if you have an invisibility cloak, the eyes of Harry Potter would be visible to the outside world. So you see two eyes floating in midair, okay?
In order that Harry would see.
Right. So that is also a problem with metamaterials, that your two eyeballs would be floating even if you are totally invisible. The way to get around this is you have to use what are called beam splitters or glass at a 45-degree angle. So only a little bit of light comes in and out so that you can see out. Otherwise, you cannot see out. You're completely enclosed inside a cylinder as light wraps around you.
So you probably need a special pair of sunglasses.
You would have to need some kind of device so that the enemy or the people outside cannot see the fact that you are two eyeballs floating in midair without a body. So that is a technical problem that we still have to work on.
All right. An atomic laser. How would that work?
Okay, well, everybody knows that laser light is made out of light, and all the photons are vibrating in unison. That's called coherence. Right. That's why laser dot light is so dazzling, because the light all vibrates in unison. Now, matter also vibrates, but it's chaotic. It's decoherent. However, recently, the Nobel Prize was given to some scientists like at MIT that created super cold materials predicted by Einstein called Bose-Einstein condensates. Bose-Einstein condensates are so cold that all the atoms vibrate in unison, so I have a gigantic atom that you can see that's visible. All the atoms are vibrating in unison on a very large scale. We've never seen this before. We call this a superatom. So all the atoms now are vibrating in unison. Now, if you shine laser light on this object, you can actually push the atoms out, and the atoms are all vibrating in unison, and you can create beams of this. This would be an atomic laser, a laser that pushes atoms, not just particles of light. Now, this has enormous implications for several directions. First is quantum teleportation. Maybe we can physically teleport atoms which are coherent and push them in the forward direction. Second, the CIA is very interested in this because this is the stuff of quantum computers. By 2020, the power of silicon will be exhausted. Silicon Valley could gradually become a rust belt, just like the rust belt of Pennsylvania. And we can enter the post-silicon era, and we could have a depression around 2020.
We could have one soon, too.
That's also possible. But in 2020, your Christmas presents are no longer going to be twice as powerful as the previous Christmas, so why bother to upgrade? Why bother to get the latest gadget when all the gadgets are equal power to last year's gadgets? So the military is interested in quantum computers, which compute on individual atoms that vibrate in unison. Now, to be fair, the world's record for a quantum computer calculation is, get this, 3 times 5 is 15. That is the world's record. But however, that was done on 5 atoms. That's not bad by computing on 5 atoms.
I suppose not.
Right, but this is certainly not any breakthrough in calculational power. But the future is obvious. You can crack any code on the Earth if you have a quantum computer, and that's where the CIA comes in.
Yeah, they'd kill for that.
Oh, yeah, definitely. And just think about it. You can break into any code on Earth with a quantum computer. Unfortunately, the ones we have today in the laboratory are very primitive, but they exist. We actually have them in the laboratory. With Bose-Einstein condensates, with all these atoms vibrating in unison, you can see these things. You're talking about trillions upon trillions of atoms vibrating in unison. That may give us a handle on quantum computers, quantum teleportation. All sorts of quantum gizmos could come out of quantum Bose-Einstein condensates.
So you're saying you would be able to crack any code ever devised by man?
Yeah, for example, many codes depend upon factorizing a number. We know that 4 is 2 times 2. That's called factorization. But if I give you a number that is 100 digits long, and I ask you to factorize it, it would take a computer several centuries, one by one. Can 2 divide into it? Can 3 divide into it? Can 7 divide into it? It would take centuries to crack a code like that with 100 digits. With a quantum computer, you could crack it in just a few minutes.
Well, if we finally get it, we'll probably outsource it to Thailand.
Well, that's always a possibility. But, Silicon Valley will be replaced. One day we'll have a quantum valley, and we'll have quantum computing laptops maybe, and the mantle will pass. And that's why nanotechnology is going to be so important in the future. We know that nanotechnology will make possible the next generation of computers in the post-silicon era.
And you see this beginning around 2020 or the end of, at least the end of silicon.
Yeah, that's right. In fact, I was in Seattle last month. I actually spoke before 4,000 Microsoft engineers. These are the cream of Microsoft's engineers. I was a keynote speaker at their conference. Bill Gates spoke 2 days after me.
Did you bring up the silicon, waste, the Rust Belt?
Yeah, well, I told them, and they said, yeah, we're gradually beginning to acknowledge that you physicists were right. You physicists have been telling us for years, watch out for around 2020. And yeah, they're coming around to that fact now. They're preparing. Microsoft is preparing by going into parallel processing. Once we get to chips that are no longer as powerful, twice as powerful as the previous year, they're going to stack them in parallel, and then software will have to work in parallel simultaneously. That's difficult. It's difficult to coordinate things in parallel. Our brain does it, by the way. Our brain is a parallel processor. You can eat and look and laugh all at the same time if you want. Actually,
they've already begun that process, haven't they?
Microsoft is beginning to look very seriously now at parallel processing because they see the end. They got to prepare for many years in the future, and they see that around 2020, we'll be computing on atoms. Your Pentium chip has a layer about 20 atoms across. That's the thinnest layer in your Pentium chip on your desk. By 2020, it'll be 5 atoms across. And when that happens, the quantum theory takes over. You don't know where the electron is anymore, and the electron leaks out, and your laptop short circuits. Kaput.
I'm sick of buying computers anyway.
And also, by the way, this is actually, I think, a blessing in disguise, because if computing power just kept on exponentially growing, eventually we would have robots perhaps smarter than us, and perhaps they would put us behind bars, make us dance, and throw peanuts at us as we dance for our robot masters. Yeah. So maybe it's a good thing that computer power will gradually begin to sputter and perhaps level off at around 2020 or so. Otherwise, robots would become as smart as us at some point.
Professor, let's just stick with that for a second. Do you think that robots or machines, if they achieve that level, would inevitably see the illogic actions and thinking of the biological human being and take action?
It's conceivable if the prime directive of a robot is to serve humans, and they decide that the way to serve humans is to treat them like babies because they war with each other, they kill each other, they slaughter each other.
Exactly.
Then to carry out their prime objective, they may decide to take over in order to protect us like children. It's conceivable. My attitude is that right now robots are as smart as a cockroach.
Right.
A retarded, stupid cockroach. But I could see the time when robots get as intelligent as a rabbit, and then maybe a dog or a cat, and then maybe a monkey.
Perhaps it's a natural evolution.
And by that time, when they start to get as smart as a monkey, decades in the future, I think we should put a chip in their brain to shut them off if they start to become murderous. But on a scale of centuries now, we may want to merge with them. This is, of course, not for us. But centuries from now, when we start to, have a rival in a computer, we may want to merge with them our descendants may have a choice. Either get old and die the old-fashioned way, or one day wake up with a body that is genetically enhanced with glass and silicon and be a Superman and live forever.
If you were offered that option,
I'd seriously consider the option of living forever. If the other option was to get old and die, and then, that's it, kaput, right? Our descendants may have that option. First of all, we are isolating the genes for aging now. We have at least 60 of them that have been pretty much looked at very carefully. And, like I said, implants are a possibility. For example, we can take now a stroke victim. This was done at Brown University. A stroke victim that is paralyzed, cannot communicate with their mother or father, put a chip on their brain, connect the chip to a laptop. They can move the cursor on the screen. And these people can play video games now. They're totally paralyzed. They can play video games. They can answer email. They can write emails. They can surf the web. And the implant is about the size of half the size of a penny. But you can imagine a time in the future when people may normally want to have a few implants in their brain and surf the web just by thinking about it.
And by the way, Professor, there was a fascinating story. I actually touched on it in the first hour. A Dr. Taylor, a brain scientist, who actually had an extremely serious stroke, and she had the opportunity to study her own brain. I mean, being a brain scientist, study her own brain, watch as her own brain began to shut down until all she had left was right brain. And she actually described it as euphoric at one point, that she was relieved of all the brain clutter, all the, the emotional clutter of years and years and years, that all dropped away, and it was euphoric, she said.
Oh, I see. But, the next step in brain science is going to be telepathy, as I mentioned in my book.
Telepathy.
Not the telepathy that you get at a circus, but the telepathy that we can begin to duplicate with MRI scans. For example, this already exists. When you tell a lie, it takes more energy because you have to know the truth, you have to cover up the truth, and you have to know the consequences of covering up the truth and implications so you don't contradict other facts.
Right.
That's a lot of energy. You could pick that up on a brain scan pretty easily. With 98% accuracy now on college students,
really,
you can pick up the brain scan of a college student who is telling a lie, because it takes much more energy than telling the truth. And this year, as I quote in my book, this year is going to go to court. There was an insurance company that deprived a claim of a man whose store burned down. The insurance company said that you set your store on fire. Therefore, we don't have to pay your insurance. He said, that's ridiculous. I'm not going to burn down my own store, and I'm going to go to court. And I'm going to have a judge look at my brain scan, and I'm going to prove to you that I am telling the truth, that I did not start this fire, and you owe me the insurance money.
Wow.
So starting this year, it's going to go to court, whether or not brain scans are reliable ways of telling the truth or not.
How reliable is a conventional lie detector at its best compared to that?
For the normal person, a lie detector is actually quite accurate. However, there are pathological liars that can control their pulse to a degree, control their sweating. That's what a lie detector does. All it does is detect anxiety, sweating of the palms so that your electrical resistance starts to drop if you lie, heartbeat, respiration rate, things like that measure nervousness, basically.
Right, but an MRI would be as accurate or more accurate?
Probably more accurate, but again, you could also say that if somebody is very anxious, then perhaps the brain lights up because the brain is more anxious.
Same problem a conventional lie detector has, actually.
However, I think eventually we'll have a encyclopedia of thought that when people think of a certain emotion, love, hate, jealousy, we'll know what that brain pattern looks like, and we'll simply look it up in a dictionary. And we'll say, oh, the person feels jealous now. Oh, the person feels anxiety. So this is coming. In other words, using brain scans to read the mind of a person. Now, this does not mean that we can read words. 1 pixel on an MRI scan corresponds to millions of neurons. But if you think of the word that may only correspond to a few thousand neurons. So I don't think we're going to be able to pick up individual thoughts racing through the brain. But I think that gross activities like lying, emotions, can eventually be picked up by brain scans. And this would give us a certain form of telepathy. We'll be able to read the mind of people who are paralyzed, people who are maybe in a coma,
right,
or maybe even criminals. Who knows?
Wow.
So this is coming pretty fast now. We're getting very good at recognizing brain patterns. And like I said, we can already attach chips to brains, and you can, begin to play with your laptop. Anything you can do with a laptop, you can do by thinking about it. And my colleague, Stephen Hawking, the cosmologist,
yes,
right now he's lost all bodily control except for his eyeballs. That's how he communicates with the world, by moving his eyes. In the future, we may want to put a chip in his brain so that he would be able to, play video games, answer email, and surf the web just by thinking.
So we really don't know enough about what he's thinking right now. It's gotten to that point.
It's gotten to that point, yeah. So, Stephen is at the point where he's lost control of his vocal cords and basically eye movements. Eye movements is the only way that we have of communicating with him. And his disease is fatal. He's lived much longer than the life expectancy of somebody with ALS or Lou Gehrig's disease. But, he still cracks jokes. He still keeps his spirit up. He still makes bets. He loses most of his bets, but he still makes bets.
It's just amazing to me, the human spirit, that given that much deterioration, still chooses life.
Yeah, the willpower. It's really a testament to a person's will, that if they really will something into existence, chances are you'll have some success. And here's a man who's totally paralyzed, who's still doing research. He's still publishing papers.
Back for a moment to teleportation, were that to become viable, even with a machine at this end and that end, it would so overturn the economy, the airlines would be gone. And now I'm talking about a mature teleportation, but you can just imagine it would change everything as we know it.
That point is still centuries away. But, transportation, buses, trains. Think of the environment. One reason why we ruin the environment is because so many pollutants in the air.
That's right.
And that could be a thing of the past. All these emissions created by transportation. Our descendants will wonder, gee, how come you guys bothered to invent the internal combustion engine when you know that you're going to have to breathe the stuff later on?
Yeah, well, it's all such a race, Professor. I mean, I just read a story a little while ago about the North Pole, after all, is one thing, but when the Antarctic begins to chafe away in large chunks, as it's seemingly doing right now, then I think we're in real trouble. And that's something I'd kind of like to talk with you a little bit about when we get back. I know you're big on the environment, and there's still a giant, well, the scientists say it's all true. Global warming is real. We'll ask if it is. Here I am. My guest is Professor Michio Kaku, and his book is Physics of the Impossible, rocketing to number 12 on the bestseller list. Not there yet, but he's received information that that's where it's going next. I had heard 18, but headed for 12, so this is going to be a big one for the professor, and so it should be. Actually, the impossibilities are classed by the professor. Class 1 impossibilities, Class 2, and Class 3 impossibilities. And I have a specific question about Class 3, but first the environment coming up next. Well, all right. Professor, gosh, so many of these things like teleportation is certainly a prime example, and many of these other impossibilities that look as though they might be on the horizon would solve so many of our problems. For example, what's going on in the world right now? We already know the ice at the North Pole seems to be melting away quite rapidly. Now we're hearing that large chunks of the Antarctic are beginning to fall away. Now, those are the ice cubes that are outside the glass being chunked in. So that seems pretty serious to me. Are these things that are coming going to come, in your opinion, quickly enough?
Well, I think every climatologist has been shocked at the rate at which the atmosphere has been changing. If you
Yes.
go back to the literature 10 years, there were dire predictions made 10 years ago. And if you go back to them from today's perspective, you realize that they were all off. They were much too conservative.
That's right.
10 years ago, nobody predicted that we would have a potential loss of the entire North Polar region by mid-century. And yet that seems to be coming. It's a foregone conclusion now among many climatologists, a foregone conclusion that we have already passed the point of no return concerning the North Polar ice sheet. And future maps of the world, pictures of the Earth from outer space, will no longer show the North Polar region. It'll just be clear ice for most of the year.
Serious,
So who would have
serious
thought
as
that?
that may be, once the ice down south begins to melt, we've got a real problem because that ice, of course, is all on land, or that is, say, above water level, and will add to the ocean level. So when you begin to hear about big chunks breaking off down there, it's time to worry.
That's right. And already there are projections as to how many dikes we're going to have to put around Manhattan, Los Angeles, San Francisco, Boston. There are maps on the Internet showing what Boston will look like by mid-century, and most of it is going to look underwater, just like it was in the pre-revolutionary days.
Yes.
And Wall Street would be pretty much underwater. And many of the familiar landmarks, especially in Florida, are going to be underwater.
Yes.
And
So again, the question is, with all these wonderful things on the horizon, they look awfully far out there when you look at the pace of deteriorating climate.
That's right. I think every climatologist underestimated the rapidity with which the seasons are changing, rapidity with which the polar regions are changing, the recession of glaciers is changing, the migration of insects is changing, the certain areas becoming more desert and extreme swings of the weather. Who would have thought that 10 years ago? All the predictions 10 years ago were much, much too conservative, as we now know.
So perhaps I ought not press you on this, but you know, these changes, it just doesn't seem like they're going to come fast enough.
Fast enough for what?
For us. For us. In other words, as quickly as the climate is changing, you know, we're talking about mid-century, being in serious trouble, and you're talking about teleportation, perhaps at a usable level a few hundred years away.
Oh, I see. Whether or not these technologies can save us from the worst effects of our own follies.
Yes.
That remains to be seen. I tend to think that a solar hydrogen economy is about 10, 15 years away. The cost of oil keeps rising. The cost of solar hydrogen keeps dropping. And within 10 to 15 years, the two curves are going to cross. And when the two curves cross, that's when we start to make the transition to a solar hydrogen economy. And beyond that, maybe fusion on a 30-year time scale, maybe fusion power. The French are putting all their eggs in the fusion basket. They're building the world's most advanced fusion reactor, the ITER, in southern France. And all the industrialized nations are chipping in money, betting that in the far future, now mid-century, perhaps fusion could kick in. My worry is that fusion may kick in too late. And by that point, we'll pass many points of no return. So it'll be beyond our capabilities to stop the melting of the North Polar region, the breakup of the South Pole, rising sea levels, growing dust bowls, migration of insects, changing of the seasons. It may not be fast enough.
I note that you class your impossibilities as 1, 2, and 3. And I remember that you had a Type 1 planet, a Type 2 planet, a Type 3, well, not planets, but
civilizations.
Civilizations, yes. 3 types of civilizations. Is it kind of like that?
Sort of. Class 1 impossibilities are impossibilities that will be possible within 10 years to 50 to 100 years. And most of what you see in science fiction, like telepathy and artificial intelligence and invisibility, most of that are Class 1 impossibilities. Class 2 impossibilities may take centuries to millennia, and that includes time travel. We think that it's an engineering problem, a huge engineering problem, but one that can be surmounted by an advanced civilization. Time travel, we think, is for maybe a Type 2 or Type 3 civilization.
All right, just run through it. In other words, tough, tougher, and toughest.
And toughest, right.
Right, okay. Class 1 would include force fields, invisibility, phasers and Death Stars, teleportation, telepathy, psychokinesis, robots, extraterrestrials and UFOs, starships, antimatter, and anti-universes. Now, we'll touch on some more of those. But way off in Class 3 impossibilities, I see you have listed precognition.
And perpetual motion machines.
Mm-hmm. But why precognition?
Well, we have two great theories of physics that we see no deviation from. We have, on one hand, the quantum theory of the atom, which gives us electronics, laser beams, the internet, iPods. Then we have Einstein's theory of black holes and the Big Bang. These are the two great theories. Now, if those two great theories were shown to be wrong or to have loopholes, then perhaps we're going to have to revise our understanding of what I call Class 3 impossibilities. But Class 3 impossibilities violate relativity and violate the quantum theory, like perpetual motion machines and precognition. Now, time travel is of a different category. We think a time machine may be possible, and we can still preserve causality, cause and effect, so that you cannot go backwards in time and your teenage mother falls in love with you and spurns your father. So how could you be born if your teenage mother fell in love with you? We think we can answer these things by having the river of time fork into two rivers, in which case you've met a teenage girl who looks like your mother, acts like your mother, is genetically identical to your teenage mother, but is somebody else's teenage mother, because you've entered a new timeline. The river of time has forked into two rivers. So we think that causality, law, the cause and effect, will still be maintained even if we have time travel.
If that occurs, does the rest of the universe change at that same instant?
That's right. Another universe would then open up at that point, and the river of time would fork into two rivers. Okay. And a time traveler has simply gone from one time stream to another time stream. So if you monkey with the past, you're monkeying with somebody else's past, not your own. So you cannot kill your parents before you're born. If you do kill your parents before you're born, you kill somebody else's parents who look like your parents when they were young, but they are not your parents. Your parents gave birth to you. So in that sense, even with a time machine, you do not have precognition.
Well, if all of this may one day be possible, then it must be going on now, which means we must be experiencing these splits now.
That's right. If you take this seriously, this is called the many worlds theory.
Or it's never going to happen.
Well, the many worlds theory is gaining in acceptance among physicists. I have several friends of mine are Nobel laureates, and they all believe now in the many worlds theory, in which case Elvis Presley could be alive in another parallel universe. We physicists take this seriously. In fact, we even say that in these other universes, you would have a counterpart, that Elvis Presley could still be alive. You could have a brother or sister that does not exist in this universe. Or maybe in the other universes, you don't exist because your parents had a miscarriage. These are all possibilities that send the mind spinning, but yeah, we physicists take these seriously.
I'm just wondering why precognition falls into a Class 3 impossibility.
Yeah, not that it is totally impossible. Class 3 impossibilities simply violate the two great theories. Now, the two great theories don't talk to each other. They're incomplete. That's where string theory comes in, which is what I do for a living. That's my day job, working in string theory.
Yes.
String theory, in fact, I'm the founder of string field theory, which is one of the main branches of string theory. The string theory now allows you to unify these two great theories, but even within string theory, we don't see any violation of causality. So that's why I'm saying that precognition may be possible, but not within the framework of known physics.
Okay.
or for that matter, perpetual motion machines. For
Well,
example,
I believe that you and I have spoken of this before, but precognition is the one thing in this whole list that I actually have experienced myself. Truly, one adult to another, no lie, no exaggeration. I experienced it. Do you recall my speaking of
no.
this?
Could you
Sure.
refresh my memory?
Sure. I lived long ago in Santa Barbara, California.
Mm-hmm.
I lived in a little, what were called garden apartments, and I worked for a radio station in Santa Barbara. And I came home from work one day, as I would do every day. I would come home from work, sit down, and watch the evening news.
Mm-hmm.
Now, I had no choice but to park my car sort of directly in front of the sliding glass doors to the apartment. So I could look right out the door and I could see my car.
Mm-hmm.
Okay. So I come home, park the car, go inside, turn on the TV, watch the news. I begin to have wave after wave after wave. That's the only way I can describe it. It was so strong that it felt like ocean waves crashing over my brain saying, your car is going to be hit.
Mm-hmm.
Your car is going to be hit. It was ridiculous. I felt it was ridiculous. So I got up, went across the room, opened the curtains, looked out at my car. It was fine. I said a 4-letter word, went over and sat back down and watched the news.
Mm-hmm.
The moment I sat down, the moment it came crashing back, someone's going to hit your car, someone's going to hit your car.
Right.
So I said another 4-letter word, got up, disturbed the newscast, which I wanted to see, went over, opened the curtains, looked out, the car was fine. But wait, here's a guy on the sidewalk walking down, and I watched him. I think it might have been during a commercial break. I watched him walk down the sidewalk, get into the car in front of mine, start the engine, put it in reverse, and crash into my car. Yeah, no joke, no lie, no exaggeration. It freaked me out so badly I sunk to my knees, but revived myself quickly enough to yell at him, hey, I saw that. Okay, I'm stopping. You know, it was no big deal, a bent fender and so forth, but nothing awful. But I tell you, Professor, I swear to you, what I just said is exactly true.
Wow, that's really spooky, huh?
Spooky, and it wasn't, it wasn't as if I saw something that was going to occur a year from now. But there was no mistaking what it was.
Right.
It just washed over me in wave after wave. Now, it's never happened since. It never happened before. But, my God, it was strong. Now, what was that?
Wow. I guess after experiencing something like that, you become a real true believer. I mean, first-hand experience, right?
I don't know what you believe in. You believe you have to start asking questions, yes.
Yeah, well, it really does kind of shake you up, when you confront it firsthand, close encounters of the third kind.
Well,
right?
okay, so in the world of physics, what could account for that?
Well, there is something in the theory of light called advanced solutions. This was an embarrassment for 100 years, but these solutions communicate with the future. We all know that when you send light across a room, light progresses in a normal way. Light does not go into the future. But if you look at what are called Maxwell's equations, they have retarded solutions, which we see all around us, which travel the speed of light. But then we also have advanced solutions that allow you to communicate with the future. So in principle, you could have a telephone conversation between the future and the past, and somebody could give you all the stock quotations of the future. Now, this was an embarrassment for 100 years. Maxwell's equations are the foundation of modern society: radio, television, antennas. If you're an engineer or physicist, you have to memorize Maxwell's equations or you cannot get your advanced degree. It's as simple as that. But Maxwell's equations have these advanced solutions. So for a while, some people thought that maybe it is possible to have a telephone conversation with the future or the past using these solutions.
But all of these things are light or sublight, right? So,
well, Richard Feynman, Nobel laureate, finally found the solution in 1949, for which he won the Nobel Prize in 1965. And it shocked the world of physics when he found the solution. And the solution is antimatter. It turns out that when ordinary matter goes backwards in time, we call it antimatter. So antimatter is ordinary matter going backwards in time. Now, you may say to yourself, well, that's bizarre, but hey,
Yes.
that won the Nobel Prize in Physics and has been verified by every experiment since then. That is the secret of antimatter. People wonder, how come nature created antimatter? It's just this extraneous double of ordinary matter. And the reason is it takes advantage of precisely these advanced solutions. So Richard Feynman showed that it is possible in some sense that matter can go backwards in time. Then you could, set up these bizarre telephone conversations. But because it is just antimatter, and we play with antimatter, causality is restored. Because even though it's matter going backwards in time, from our perspective, we go forwards in time, cause and effect are still established. So what Richard Feynman did was he plugged the loophole, this loophole of being able to see the future, which was an embarrassment ever since 1860 when Maxwell first wrote down his equations. So it explained the mystery of antimatter and the mystery of whether or not you could have a telephone conversation with the future. But, I guess when you experience it firsthand, though, it really shakes you up.